skyscrapers.
They were really huge. You know, I noticed some of those aren't exactly accurate. The Twin Towers aren't up anymore. And the One World Trade Center is currently the tallest building in America. And I think it's taller than the Twin Towers were.
It was. It's taller than, it's 1,776 feet.
That's a lot of feet.
Which is kind of interesting because 1776, that's the year the Declaration of Independence was signed.
That's
They did
really
that on
cool.
purpose. Yeah.
Wow.
Yeah. And the last two buildings in that video aren't actually completed yet.
Oh, that's right, because the video does go into the future, into 2022 or something like that.
Yeah, so the Burj Khalifa remains the tallest building in the world at this time.
Wow, now I know we're talking about water, but how do they get water all the way to the top of the Burj Khalifa if it's the tallest building?
Well, that is why we're talking about this today. Good question, Mr. Kyle.
Thanks.
There are a lot of challenges to building the world's tallest skyscrapers. We all know that you have to think about how strong your building materials are. And if you don't want the weight of the upper building to crush the lower building, you need to think about the weight of the materials that you're using. Funny, weather is a huge thing when considering how to build a skyscraper. For instance, the Burj Khalifa in Abu Dhabi is a lightning rod. Like, lightning hits it all the time because it's the tallest thing in the city. And a challenge everywhere for skyscrapers is wind. They're constantly trying to make buildings that can flex with the wind and counteract the wind. But something we don't take time to think about very often is how to bring water and electricity and things like that into these huge skyscrapers. Last week, we started to talk about the weight of a column of water, and that plays a huge role in how to get water to all 9,000 bathrooms in the Burj Khalifa.
So like we talked about last week, water is really good at climbing things, but we also know that water is heavy. Like this experiment, the water is able to go up the paper towel, but only to a certain point before the weight of the water is too much for its ability to climb, because we know water gets heavy, and the higher it gets, the heavier it gets, like this column of water. If you have a 1 cubic foot of water, or 7.48 gallons of water, it weighs 62.43 pounds, which is pretty heavy. Some of our third graders weigh that much. Like, it's hard. It would be hard to carry that all the way up to this tall building. And the way that they solve this problem is by pumping the water, not all the way to the top, but in sections. So that every 40 floors, the water hits a swimming pool size tank, and then they pump it up another 40 floors and another 40 floors until it gets to the top, and it comes down under its own weight to all the facilities that need it. And that's why you can't pump the water just straight up, because if you lifted that many feet of water straight up, it would weigh over, or exactly, 169,622 pounds. We can't make a pipe that strong. It would burst the pipe. You can't set that much weight on a pipe and expect it to hold.
Oh, we have a great video that talks about that.
Yes, we do. Watch that now.